In this video, we are going to discuss the limits of exponential functions. The objective in this lesson is to understand further and learn how to compute limits of exponential functions. Let's get started.
Attention, our dear students. For the last question in our basic calculus quiz B 2025 that is equivalent to 10 points. What laws of limit you will apply when solving limit of 4 raised to x minus 1 over 2 raised to x minus 1 as x approaches to 0? Yes.
I think the answer is quotient law.
No, it's law of exponential.
Yes, it is correct, because limits of exponential functions tells us that if b is greater than 0 and limit of f of x is equals to L as x approaches to a, the limit of b raised to f of x is equals to b raised to L as x approaches to a. Finding the limits of exponential function is similar to finding the limits of algebraic expression. The theorem can be simplified as limits of b raised to x is equals to b raised to a as x approaches to a.
When we say exponential function, it is a function in which the exponent of the expression has a variable denoted as f of x is equal to a raised to x, where the value of a is a constant. And it has to satisfy the condition that a is greater than 0 and not equal to 1, while the variable x is the exponent in which its domain is an element of real numbers. Now let us recall the graphs of exponential functions. First, if the base a is greater than 1, then the graph increases. As x increases, and it is very obvious by looking at this graph, again, as x increases, y increases. On the other hand, if the base a is between 0 and 1, then the graph decreases, meaning as the value of x increases, y decreases. To further understand,
Linux, can you give us an example to further elaborate?
Example number 1. Limit of 3 raised to x as x approaches to 4. In this equation, we will apply the direct substitution, which is direct substitution is directly replacing the variable in a function. So our equation would be 3 raised to 4. Since our value of x here is 4. So our next step will be 3 raised to 4 will be 3 and the answer will be 81. For our problem number 2, the given here is limit of 5 raised to 2 times x times 1 as x approaches to 2. So in this problem, we will still apply the direct substitution. So our equation would be 5 raised to 2 times 2 minus 1. So we will still copy the x here, the value of x here. So our equation would be 5 raised to 4 minus 1 is 3. 5 raised to 3 will be the answer will be 125.
Another example of limits of exponential function is limit of 2 raised to x as x approaches to negative 3. We will simply substitute the negative 3 as x. Then we will apply the law of exponent, which is the negative law of exponent. It will be 1 over 2 raised to positive 3, and 2 raised to 3 is 8. This is our final answer.
Problem number 4. The limit of 1/4 quantity raised to x plus 2 as x approaches to 1. So we will just substitute the x with 1 as the value of x is 1. So it will be 1/4 quantity raised to 1 plus 2. We will just simply add the 1 and 2. So it will be 1/4 raised to 3. So we will distribute the 3 to numerator and denominator. So it will be 1 raised to 3 and 4 raised to 3. Is equals to 1 raised to 3 is 1 and 4 raised to 3 is 64. So the answer is 1/64. Now, because we cannot solve this equation by directly substituting, we will first factor it, then substitute. So this will become limit of 2 raised to 2x minus 1 over 2 raised to x minus 1 as x approaches to 0. By factoring, this will become 2 raised to x minus 1, then 2 raised to x plus 1 over 2 raised to x minus 1. So we will simply cancel economic terms. With this, we will now directly substitute the value of x, which is 0. 2 raised to 0 plus 1. So this goes to 1 plus 1. So the answer, or the final answer, will become 2.
Now you've learned how to find the limits of exponential functions. Let's see if you can do it on your own.
To test if you clearly understood our topic today, try to solve these problems on a piece of paper by applying the limits of exponential function.